This is a long answers Algebra 1 Regent question from the January 2016 Regent. The function t of x is shown in the table below, and then they give us a table. Determine whether t of x is linear or exponential and explain your answer. Linear models, linear functions, always have a constant rate of change between consecutive points. For example, say we have a graph and we have points. The slope between each of these points is going to be the same thing. The slope between here and here is the same. The slope between here and here is the same. Slope between here and here is the same. That an exponential is never like that. Exponential is going to look something like that. And the slope between this point and that point is different than the slope between this point, and that's very obvious. The one that we drew second, the one that's now in purple, that one is obviously much steeper than the one in blue. So whenever we're asked to determine whether a model is linear or exponential, we want to see, is there a constant slope? Is the rate of change, is the slope between consecutive points, is it the same over the entire interval? So what we need to do is we need to find the slope between each of these points, between -3, 10 and -1, 7.5. Between -1, 7.5 and 1, 5, between 1, 5 and 3, 2.5, between 3.5, 3, 2.5 and 5, 0, and see if we're going to get the same slope over the entire interval. The way we find slope is delta y over delta x, the change in the y values over the change in x values. So let's start with our first 2 points. -3, 10 and -1, 7.5. And let's look at delta y over delta x. The change in our y values is 10 minus 7.5. The change in our x values is -3 minus -1. 10 minus 7.5 is 2.5. -3 minus -1, or -3 plus 1, is -2. And we can just solve it on the calculator to reduce this. Give it to us as a decimal. 2.5 divided by -2 is -1.25. So this is going to be the slope between the first 2 points. Let's look at the next 2 points. Our next 2 points are -1, 7.5 and 1, 5. Let's find change in y over the change in x. Change in y values, the first y value is 7.5, minus our second y value is 5. Change in our x values is -1 minus our second x value, which is also 1. 7.5 minus 5 is 2.5. -1 minus 1 is -2. And if we reduce that on the calculator, it's the same. We can see that our fraction is the same thing as the one above, 2.5 over -2, which is -1.25. So between the first 2 points, we have a constant rate of change. We have to check each of them, because let's say between 3, 2.5 and 5, 0, there's a different slope, then it's automatically not linear, even though we already have that between two of the points, it is a constant rate of change. Our next 2 coordinates are 1, 5 and 3, 2.5. Now let's find the change in y values or the change in x values. Change in y values, 5 minus 2.5. Change in x values, 1 minus 3. 5 minus 2.5 is 2.5. 1 minus 3 is -2, which is the same fraction as before, so reduce that would be -1.25. Let's just look at our last set of coordinates. 3, 2.5 and 5, 0. Change in y values, 2.5 minus 0. Change in x values, 3 minus 5. 2.5 minus 0 is positive 2.5. 3 minus 5 is -2, which is the same as the fractions we got before, so our rate of change is -1.25. Like all the rest of them, since there's a constant rate of change between consecutive points, this is linear. This model is linear. We needed to explain the answer. There's a constant rate of change between all of the consecutive points.